वेलकम डियर स्टूडेंट, वेलकम टू माय चैनल टॉकिंग फिजिक्स विद पीआर सरकार। आपका अपना पीआर सरकार सर दसवीं। तो बच्चों, आज हम जानेंगे एक नई टॉपिक के बारे में जो है कि कैपेसिटेंस। आप लोग कैपेसिटेंस के बारे में थोड़ा बहुत जानते हैं। आई होप कि आप लोग पता है कि कैपेसिटेंस क्या है, लेकिन आज हमारे जो पॉइंट ऑफ व्यू होगा कैपेसिटेंस के बारे में वो कुछ अलग ही होगा। ठीक है, सो देखते रहिए लास्ट तक। ओके, स्किप मत कीजिएगा, क्विट मत कीजिएगा, कुछ नए सीखने को मिलेगा। आई होप आपको अच्छा लगेगा वीडियो। तो शुरू करता है कैपेसिटेंस, बेसिक प्रिंसिपल ऑफ कैपेसिटेंस। तो वी नो दैट एनी चार्ज conductor of any arbitrary shape is a capacitor. Any charge conductor is called capacitor. So the name capacitor comes from capacity or ability to hold charges. Capacity or ability to hold charges. So we know that the charge of a conductor is proportional to its potential. When a particle is charged, then its potential is increased. But मेरा जो क्वेश्चन आपसे है वो है कि क्या हम कोई भी कंडक्टर को या कोई भी कैपेसिटर को एंडलेसली चार्ज दे सकते हैं, कि अनलिमिटेड चार्ज दे सकते हैं या नहीं? अगर दे सकते हैं तो कितना मैक्सिमम चार्ज एक कंडक्टर को देना चाहिए, और कितना अगर नहीं दे सकते तो क्यों नहीं दे सकते हैं? अगर आपको पता है तो ठीक है, इट्स ओके, और नहीं पता है तो प्लीज लास्ट तक वीडियो को देखिए। सो Q is proportional to V. Now what is the maximum charge given to a conductor? What is the maximum charge given to a conductor? Suppose if we draw a conductor of like any random or arbitrary shape, किसी भी शेप का अगर हम एक कंडक्टर को ऐसे ड्रॉ करते हैं, ये इसका शार्प एज है, ये जो एज है ये है शार्प एज, तीखा। शार्प मीन्स तीखा, पॉइंटेड। और ये जो सरफेस है ये है फ्लैट सरफेस और फ्लैट एज। तो अगर किसी भी चार्ज Q को हम इस कंडक्टर में देते हैं तो वो इसमें डिस्ट्रीब्यूट हो जाएगा। जो शार्प एज है वहां पर सरफेस चार्ज डेंसिटी कम होता है, दैट इज जो शार्प एज है वो सरफेस चार्ज डेंसिटी ज्यादा होता है। यहाँ पर जो सरफेस चार्ज डेंसिटी सिग्मा दैट इज Q अपॉन 4πr², ये लार्ज है। और ये जो फ्लैट सरफेस है ये भी फ्लैट सरफेस है, यहाँ पे फ्लैट सरफेस है, यहाँ जो सरफेस चार्ज डेंसिटी कम होता है, इसीलिए यहाँ पर ज्यादा चार्ज नहीं है, यहाँ पर चार्ज जो डेंसिटी है ज्यादा होता है। So when we placed this conductor in a dielectric medium, you know that the dielectric medium is medium in which the positive charge and negative charge are distributed. Positive and negative charge are distributed along a particular direction. Positive charge are situated in a particular direction, negative charge are distributed in a particular direction. So when we can place a conductor in a medium, any surrounding medium, then the dipole that is plus minus charge, plus minus, as plus charge is given to the conductor, then the electric field is away from this, that is it is perpendicular to the surface and direction is radially outward. The electric field is act along this direction, perpendicular to the surface and radially outward. So when we placed the conductor in a dielectric medium, its dipole, that is the negative charge, is attracted towards positive charge in this manner. Obviously, the electric field gets a force on them, force on dipole. Now, if we increase the charge of this conductor, that is, if we give more and more charge from outside to this conductor, the force will be exerted on the dipole more. As this is positive charged, the positive charge of dipole is moved along this direction, and the negative charge is moves along this direction. That is, positive charge becomes repulsed and negative charge becomes attracted towards the conductor. So the maximum strength of this dipole, for which it experiences maximum force, is known as dipole strength. Dipole strength. The maximum force, or maximum, we can say it, the maximum tolerance, that is, जितने भी force ये सहन कर सकता है before breakdown, it is called dipole strength. But when the charge is going to a certain limit, so इस जब चार्ज का जो लिमिट है, एक कंडक्टर का चार्ज जो लिमिट है, वो जब एक सर्टेन लिमिट में पहुंच जाता है, say it maximum limit, then the stretching of the dipole becomes maximum and it crosses its breakdown strength. It crosses its breakdown strength. Breakdown strength क्या है? When the force, जब फोर्स बहुत ही ज्यादा है इसमें, तब क्या होता है, ये पॉजिटिव चार्ज इधर मूव कर रहा है, नेगेटिव चार्ज इधर मूव कर रहा है. दैट इज, इट इज बिकम स्ट्रेच्ड एट अ सर्टेन पॉइंट. When the force is when the charge is maximum, the force is always maximum, then the dipole in the medium breaks down. That is the dipoles seems to be like this, the positive charge, negative charge. This is breaks. The dipole will be breaks. That is, positive charge of the dipole moves away from the conductor and negative charge get attracts from the conductor. This will be more and more occur at the sharp edge. The sharp edge, this breakdown is more surface, this force exerted is more, and the flat surface, this force exerted is less. So the positive charge moves along away from the conductor and negative charge moves towards the conductor. As a result, it will seems that a charge is leaking of charge. ऐसा लग रहा है कि चार्ज लीक कर रहा है, leaking of charge. Charge is leaked from the conductor. So when charge is leaked, the breakdown strength. What is breakdown strength? I repeat, breakdown strength is when the dipole becomes breaks due to force of electric field due to charge on the conductor is known as breakdown strength. So जब डाइपोल टूट जाता है तो लगता है कि चार्ज लीक कर रहा है from the vicinity of the conductor. So this is the basic phenomena of capacitance. So we cannot give the conductor so much charged, because after a certain limit it becomes a leaked charge. So the maximum charge of the conductor depends upon the value of capacitor. So the maximum charge of conductor depends upon the value of capacitor. तो हम लोग ये जाना है कि there is a certain limit of charge. We cannot give it endlessly or unlimited charge to a conductor, because for this the surrounding medium dipoles becomes breakdown and charge will leak. So as the charge is directly proportional to the potential difference, then Q is proportional to V. So Q समान equal to CV. So for V equal to 1, Q equal to C. That is, capacitor is nothing but charge for rise 1 volt of potential difference, for the unit rise of potential difference. So capacitance is charge needed to rise to unit rise in potential difference. Charge needed to unit rise in potential difference. So this is the capacitance. This is a obviously constant. So if we draw graph between Q and V, it becomes straight line because proportional. Q is proportional to V. But if we put a graph between C and V, C is constant, so this is the parallel to x-axis. Now, if a single conductor gives charge for a given potential, the capacitance is produced is known as self capacitance. Any single capacitor or any single conductor को जो चार्ज देता है और इसके लिए जो कैपेसिटेंस बिल्ड होता है उसको कहते हैं सेल्फ कंडक्टेंस. Again we go for a capacitance of more than 2 capacitor. इसके लिए कैपेसिटेंस क्या होगा? We know the definition of potential. What is the definition of potential? That the potential at point P is to move a unit positive charge. Potential of point P is to move a unit positive charge from infinity to point P is the work done required to move a unit positive charge from infinity to point P is known as potential of that point. That is, for ideal case, the electric field is extends to infinity. Electric field infinity तक सोचा जा सकता है. But in practical, for our convenience, we consider that there is a body, there is a charge body placed in front of conductor, and this is any charge body. That is, here we cannot say the reference point as infinity at a certain limit. This is, we know that we give the name A and B. So this is positively charged, and when we can bring charge from body to this conductor, so the charge will be less, the charge, positive charge will be less in conductor, in body B. So the body B becomes negatively charged. When charge comes from, positive charge comes from B to A, then the deficiency of positive charge occurs in B. So the B becomes negatively charged. So for this, the electric field of lines becomes start from A and terminate at B. We know this diagram. This type diagram, okay. जब B से पॉजिटिव चार्ज को A में लाना पड़ेगा तो B में नेगेटिव चार्ज का जो डेंसिटी है वो इंक्रीज हो जाएगा। और इलेक्ट्रिक फील्ड ऑफ लाइंस, ई फील्ड ऑफ लाइंस वी नो गोज फ्रॉम पॉजिटिव टू नेगेटिव चार्ज बॉडी। So in this case, the capacitance is built between them, A and B, is known as mutual capacitance. If the potential of A is VA and potential of B is VB, then VA minus VB is the potential difference between A and B. Then the capacitance C is total charge upon VA minus VB. This is known as mutual capacitance. So for a single body, the capacitance is said as self-capacitance. For more than two conductor, the capacitance is said as mutual capacitance. Okay. I hope theory आपको समझ में आ गया है. Now we go for the unit of capacitance. Unit of capacitance C is Q divided by V. Q is coulomb per volt. It is known as F, that is farad. According to Michael Faraday name, this is known as farad. 1 farad is very large. 1 farad is very large. So in practical, we can write the unit of capacitance as millifarad, microfarad, picofarad. Milli means 10 to the power minus 3. Micro, you know, 10 to the power minus 6. Pico, 10 to the power minus 12 farad. Why we don't use F as practical unit? So for this, we have to calculate the capacitance of a spherical conductor. Capacitance of C, you can say C as capacitance of spherical conductor. If there is a spherical conductor, sorry, ये sphere नहीं हुआ, spherical conductor, and we give it positive charge Q, it is assumed that the charge is concentrated at its center. मैंने ये पहले बोला है, okay? So if the radius of this sphere is R, then what is the value of potential at the surface? V is equal to, we know, 1 upon 4 pi epsilon naught Q by R. Therefore, capacitance C equal to Q by V. So Q divided by, put the value 1 by 4 pi epsilon naught Q by R. Q will be cancelled. Therefore, you can get C is equal to 4 pi epsilon naught R. Very, very important relation for doing numericals. अगर CGS यूनिट होता तो C इक्वल टू R होता. CGS में कैपेसिटेंस जो हो, जो कैपेसिटेंस का वैल्यू जो होता है वही रेडियस का वैल्यू होता है इन CGS यूनिट, but their unit is different. This is known as farad or picofarad. This is semi-on meter. But at SI, C equal to 4 pi epsilon naught into R. Okay, now if we take C equal to 1 farad, then what is the radius of this sphere? R equal to becomes C by 4 pi epsilon naught. So 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into 1. That is 9 into 10 to the power 9 meter. Okay, so 9 into 10 to the power 6 kilometer. 9 into 10 to the power 9 meter means 9 into 10 to the power 6 kilometer. अब अर्थ का रेडियस क्या है? अर्थ का रेडियस है 6400 किमी. That is, if we take the ratio of R1 and R, we can get that R1 is करीब 1500 times of R. That is, if the capacitance of a sphere is 1 farad, then its radius होता है 9 into 10 to the power 6 किलोमीटर, और अर्थ का जो रेडियस है उससे 1500 गुण बड़ा होता है. So farad is not a small quantity, it is very large quantity. I hope आपको समझ में आ गया है. अभी हम लोग एक छोटा सा न्यूमेरिकल देखेंगे. तो फर्स्ट न्यूमेरिकल है कि दोनों न्यूमेरिकल है, हम दोनों न्यूमेरिकल एक साथ ही करेंगे। तो सपोज एक स्फीयर है, स्फीयर इज गिवन जिसका कैपेसिटेंस इज गिवन बोल 50 पिकोफैराड। ओके, we have to find out its radius. We have to find out its radius. We have to find out its radius and what amount of charge is given so that its potential increase 10 to the power 4 volt. एक स्फीयर है, उसका जो कैपेसिटेंस वो गिवन है, उसका रेडियस हमको निकालना होगा और हमको बोल रहा है कि अगर इसका पोटेंशियल 10 to the power 4 वोल्ट इंक्रीज करना है तो हमको व्हाट शुड बी, वी हैव टू गिव चार्ज। सो क्या होगा, वी नो दैट C इक्वल टू 4 पाई एप्सिलॉन नॉट R, सो R becomes C by 4 पाई एप्सिलॉन नॉट। 4 pi epsilon naught is 1 by 4 pi epsilon 9 into 10 to the power 9. C is given 50 picofarad, that is 50 into 10 to the power minus 12. This is meter. So 450 into 10 to the power minus 3 meter. 450 into 10 to the power minus 3 meter. Okay, that is 10 to the power minus 3 meter, that is 45 into, okay, यही रखना पड़ेगा, 450 into 10 to the power minus 3 meter is just answer. You can convert it into centimeter. Okay, now what is the value of Q? Q equal to CV. Put the value of C, that is 50 into 10 to the power minus 12. Okay, and V is given 10 to the power 4, that is 50 into 10 to the power minus 8 coulomb. Okay, very basic. छाप लो उसको, पोंछ दे। ओके, अगर ये सीजीएस में होता तो ये टर्म नहीं होता, C इक्वल टू R हो जाता डायरेक्ट। नेक्स्ट प्रॉब्लम, सपोज एक रेन ड्रॉप है, उस रेन ड्रॉप का हमका जो रेडियस है बोला गया 3 मिलीमीटर। ऐसे 127 रेन ड्रॉप कोलैप्स्ड टू फॉर्म ए लार्ज रेन ड्रॉप। फाइंड आउट द कैपेसिटेंस एंड पोटेंशियल ऑफ दिस रेन ड्रॉप। Okay, so we have to, sorry, this radius we can say small r, and radius of large raindrops becomes capital R. So as the we can say that the volume of each small raindrop is 4/3 pi small r cube. Okay, so the volume of large raindrop is 4/3 pi capital R cube. It belongs, ये sorry 27 into वॉल्यूम ऑफ एक छोटा सा रेन ड्रॉप, 27 छोटा सा रेन ड्रॉप मिलकर ही बड़ा रेन ड्रॉप हुआ है, तो द वॉल्यूम ऑफ लार्ज रेन ड्रॉप्स बिकम 27 into स्मॉल रेन ड्रॉप. So 435 cancelled, r cube becomes 27r cube, r becomes 3r. 3 into r is 3 millimeter, that is 3 into 10 to the power minus 3 meter, that is 9 into 10 to the power minus 3 meter. What is the capacitance of the large rain drop? So capacitance of large drop becomes C equal to 4 pi epsilon naught r. 4 pi epsilon naught is 1 by 9 into 10 to the power 9. ये बात ध्यान में रखना, 1 by 4 pi epsilon naught equal to 9 into 10 to the power 9, but 4 pi epsilon naught equal to 1 by 9 into 10 to the power 9 multiplied by this term 9 into 10 to the power minus 3. Unit क्या होगा? Farad, because it's SI unit. So 99 cancel out. 10 to the power minus 12 farad, that is 1 picofarad. So वो बड़ा एंड ऑफ का जो कैपेसिटेंस है वो 1 पिकोफैराड होगा. व्हाट अबाउट V? V निकालने के लिए टोटल चार्ज बाय टोटल कैपेसिटेंस. ना टोटल चार्ज इसकी 27 इंटू स्मॉल चार्ज. अब चार्ज बोला है कि एक एंड ऑफ का चार्ज सपोज कह दिया कि 10 टू द पावर माइनस 12 कूलम. सो पुट इट 27 इंटू स्मॉल क्यूब डिवाइडेड बाय कैपिटल C. सो 27 इंटू स्मॉल क्यू मीन्स एक, ये स्मॉल क्यू एक एंड ऑफ का चार्ज है. सो टोटल चार्ज होता है 27 इंटू एक एंड ऑफ का चार्ज divided by total capacitance. We can find out 1 picofarad, that is 10 to the power minus 12. So this will be cancel out. We can get 27 volt. So I hope आपको समझ में आ गया है आज का लेक्चर. प्लीज स्किप मत कीजिए, थोड़ा सा सब्र कर लीजिए, क्योंकि हम लोग अपनी डेली लाइफ में बहुत ज़्यादा समय को इन्वेस्ट करते हैं, वेस्ट करते हैं, लाइक सोशल मीडिया, हाँ, गपशप में, या कोई भी मूवी देख रहे हैं. जस्ट यूज योर 10 to 15 मिनट्स टाइम वाचिंग माय वीडियो. ओके, आई होप और कि आपको जरूर कुछ सीखने को मिलेगा. सो फॉर टुडे, इफ यू लाइक माय वीडियोस, प्लीज इफ यू लाइक माय वीडियोस एक लाइक कर देना, कमेंट कर देना, और अगर चैनल को अच्छा लगे और मोर चीज जानना है तो for the new upcoming videos, subscribe my channel. Thank you very much for supporting. Okay.